Hello everyone, today I want to explain about the positive Tollens test. What is the Tollens reagent? Ammonical silver nitrate. Keep in mind, what is the Tollens reagent? Ammonical silver nitrate solution is called Tollens reagent. Aldehydes react with the Tollens reagent in basic medium. It form a silver mirror or a black color solution is formed. Generally silver mirror for everyone know. And this carboxylate ion form in basic medium and 4 ammonia 2H2O. This is a balanced chemical equation for aldehyde react with the Tollens reagent. So now keep in mind here oxidation state of silver is +1. Here oxidation number of silver is 0. +1 to 0, it means this is reduced itself. Therefore, aldehyde is oxidized. Here how many oxygen? 1 oxygen. Here how many oxygen? 2 oxygen. Addition of oxygen is called oxidation. Therefore, aldehyde oxidation reaction and Tollens reagent is reduced itself. If you write the ketone react with the Tollens reagent, then no reaction, there is no change. Because Tollens reagent is a mild oxidizing agent. What is this? Mild oxidizing agent. So which is more reactive generally? Aldehyde is more reactive. That's why react with the mild oxidizing agent also. But ketones are little less reactive, therefore not react with the Tollens reagent. Therefore there is no positive test. It is a negative test. Now here I given some of the compounds and their Tollens test, positive or negative, we'll discuss. So now aldehydes, now only discuss, this gives a positive test, then it gives okay, a silver mirror possible. Ketones not possible, therefore negative test. But alpha hydroxy ketones will give the positive test. Hemiestals, that also gives the positive test. In basic medium, this hemiestals is reversible reaction. Therefore, these are converted into back as aldehyde. Alcohols do not, because there is no aldehyde group in this one. Therefore, not gives any positive test. Therefore, it is a negative test. So, this is negative and this is negative. So these are the positive tests you have to remember: aldehyde, alpha hydroxy ketone, and hemiestals. In case acetols are there, keep in mind acetols will give the negative test. First of all, you should know that what is the hemiestol. Hemiestol mean what is that? If it is a aldehyde group, then here OH one hydroxy group, one OR alkoxy group, remaining H aldehyde H. This is called hemiestol structure. This is another one. Acetol meaning what is that? Here OR both are alkoxy group and this is H. So this is acetol. Acetols are stable in basic medium, do not reverse. Therefore, acetol do not give the positive test. Now here given some of the example, then we have to find out which gives a positive Tollens test. So I'm writing here this is a Tollens test. So which will be give the Tollens test positive, we'll decide now. Here this is a keto functional group. What is this? Keto functional group. Therefore no positive. It do not respond with the Tollens reagent. Here what is the group? Aldehyde group. Therefore it will give the positive test. Here aldehyde group is there and here double bonded, then any possibilities are there, meaning anyway aldehyde is there, it gives a positive test. But in case if it is given like this, CH3 CH double bond, CH, CH double bond, CH, OH. Then this will give a positive test or not. Then the question is, this will be enolized. So this will come to here and this will comes to here, this will comes to here. This H will bonded to this carbon. Therefore, it will convert into aldehyde. Therefore, it gives a positive test. Now you observe this one. On this carbon, one hydroxy group is there, one methoxy group is there. It means alkoxy group type. Then this is called hemiacetol. Hemiacetol. Hemiacetols are gives a positive Tollens test. Then next, in this one, on this carbon, we have two alkoxy group. This is therefore this is called acetol. Acetol do not respond with the Tollens reagent. Next, this is a carbon. On this one is alkoxy group, one is hydroxy group. This is cyclic hemiacetol. Therefore, this one also gives a positive test. Glucose in Hayward structure. It also a hemiacetol. Hemiacetol. You can check in the biomolecule chapter glucose structure. Therefore, it is also shows the a positive test. Anyway, it having aldehyde group, but maximum it exists in the alpha beta form. Therefore, there are alpha beta structures are hemiacetal structure. That hemiacetal structure in basic medium converted to open chain possible. Therefore, it gives a positive test with the Tollens reagent. But keep in mind, according to the biomolecule chapter, alpha beta structure are little greater quantity than the open chain structure. Open chain structure percentage is very small concentration. Therefore, this small concentration gives a positive test. When it gives the positive test, when it react with the Tollens reagent, then that uh, actually these are alpha beta are equilibrium with the open chain. Then open chain react with the Tollens reagent. Mean according to Lee-Chandler principle, one of the side that the product is disappear mean Lee-Chandler principle, which side is that is disappeared, that's a reaction move forward. Therefore, again it convert into a open chain structure. That's what is possible. Similarly, fructose also, this will be in enolization. Fructose convert to glucose in basic medium. That's why fructose keto group present, but also it shows the a Tollens positive test. Glucose having which one group? Aldehyde group. Keto having which one? Uh, sorry, fructose having keto function, but also it convert into a glucose in basic medium. Therefore, it shows like this. In case if they give sucrose, sucrose and lactose and maltose and polysaccharide. If you take this polysaccharide, what are the polysaccharides? Starch and cellulose, glycogen. These will give the any positive test or not. Mean this sucrose do not having any hemiacetal structure or normal aldehyde group, not possible. That's why this will not show. This is a non-reducing sugar. Like this you maybe studied that non-reducing sugar, because according to the previous equation, aldehyde is oxidized and Tollens reagent is reducer. So that aldehyde act as a reducing agent, Tollens act as an oxidizing agent. That's why this product is non reducing agent. But in lactose, we have one side hemiacetal structure, therefore it gives. In maltose also we have the hemiacetal structure, it gives the positive test. All polysaccharide do not react with the Tollens reagent, they give the negative test. So starch is a polysaccharide because these are continuation polymer structure, hemiacetal structure not present. because these are in the form of continuation polymer structure, they are acetal form. Therefore these will not give the any positive Tollens test. Similarly you can apply for the failing test, but for example if I take the benzaldehyde, then what happened here? We have aldehyde group, therefore Tollens test positive, but failing negative. This do not gives reason aldehyde group, but also aromatic aldehydes are less reactive than the aliphatic aldehyde, therefore do not gives a positive test. Reason it due to resonance one. Another one, in failing reagent we have Cu plus 2 ion. According to electrode potential value, if you consider silver electrode potential value is 0.80 volt, copper value is 0.34 volt. Therefore, higher the positive value, that is a good oxidizing agent. Therefore, with this mild and very mild oxidizing agent, and this is a less reactive. Therefore, benzaldehyde is very less reactive. Do not react with the failing reagent, but react with the Tollens and gives a positive test. That is the difference.